Hello everybody, now we already know how to connect a LED. We know that we need a resistance in series with the LED, and we know that the LED has an anode and a cathode, and that we have to connect the positive part, the positive terminal of the battery to the anode, okay, which is the longest leg of the LED. Okay, what else? I forgot to tell in the previous video number 6, that we may use LEDs of different colors. Okay, we've got different colors in the workshop. All of them, they work the same. Okay, so for example, we're gonna use the red light. Okay, how to use the multimeter to measure the voltage, potential drop. Let's stop the simulation. Okay, so here, like after the battery is providing, it should provide 4.5, isn't it? It provides 4.48. okay, like a very small amount is lost. But how many potential drop there is in the resistance, and how many potential drop there is in the LED light? Okay, we can measure it. Let's put here and here to calculate the potential drop of the resistance, and here to calculate the potential drop of the LED light. Let's start simulation. It is the same amount, isn't it? 4.48 volts, which is the total potential drop of the battery. As we know, because of second Kirchhoff's law, the circuit is correct. Okay, how to calculate now the current that circulates in this circuit? The two components are in series, so let's change the multimeter to amperes, and this negative part of the multimeter, we are gonna connect it here so we can continue the series, and to the negative part. If we start simulation, 11.3 milliamperes. So after that, you have to build this circuit in the protoboard, measure everything with the multimeter, and also solve the circuit into your notebook so you can check that the results that you obtain in Tinkercad and your notebook are exactly the same, and the result that you obtain in the real circuit that you have built in the workshop, it's really similar. See you next video.